Okay, folks, let's take a look at this example problem. Again, you got a beam that has a load on it. We give you the beam cross section and we say, hey, let's determine the maximum bending stress. Again, like we said before, though, pay attention to the units. So, again, we don't give you a moment, but you're given this, loaded beam. From any loaded beam, you should be able to derive the shear diagram and then ultimately the moment diagram. If you're asked for maximum bending moment, you want to use the maximum bending stress. You want to use the maximum bending moment. So again, these reactions are important. You got to get the reactions right. This is a real easy problem, so the reactions, I think you can tell me, are 5 kips apiece. Shear diagram, moment followed by moment diagram. Shear diagram goes up to 5 kips, goes on over, the 10 kip load drops it down, on over and back up. Okay, so pretty basic, straightforward shear diagram. Then we just look at the areas. We know where it crosses 0, the shear diagram, that's going to be your location of maximum moment. So this area is 25 foot kips because I have 5 kips times 5 feet. This area is minus 25 foot kips. So again, moment diagram starts out at 0, goes up to a maximum of 25 foot kips, and then decreases back down to 0. So my maximum moment is 25 foot kips. So my moment, 25 foot kips. What's the C distance? The C distance, again, remember we talked about there being a neutral axis. If this is a homogeneous beam, a symmetrical beam, this centroidal axis is going to be the neutral axis. So the C distance, we talked about this before, typically we're going to take it from the neutral axis to the outside edge. Okay? And that's typically the case because if we want maximum bending stress, the outside edge is going to be where maximum bending stress is. Now C doesn't have to be that. I mean, I could look for bending stress 2 inches down from the neutral axis, but in this case, we're going to take it to the outside edge. And what would my C distance be then? 10 inches. And then the last thing would be moment of inertia. Now I've already said, hey, this is the sort of the axis that I'm interested in. Do we know what the moment of inertia of that rectangular shape is? We know a formula for it, don't we? Okay? That formula for a rectangular shape about its centroidal axis is 1/12 base, it's 10 inches, height, 20 inches, and I cube the height. Okay? I think that moment of inertia comes out to be, if I round it, 6,667 inches to 4. Okay? So now really I just got to plug in M, C, and I into this formula. Okay? 25 foot kips times 10 inches divided by 66, 67 inches to the 4th, and you're going to tell me what? Yeah, you want to at least bring feet into inches. You might think about bringing kips into pounds, but at least feet into inches. Okay? So I'll multiply that by 12. And when you calculate your bending stress now, I've got 300 inch kips times 10 inches divided by 66, 67 inches to the 4th. And that's going to come up with what? Well, 0.45. Units will be what? KSI. So about 0.45 KSI.